Hello, everybody, and welcome to Handmade Hero, show where we code a complete game live on stream. All right, we already actually installed that in the pre-stream, so we don't need to. I've updated to Remedy 0.2.2 today, and there really isn't probably anything you need to know about that other than it just fixes and improvements to the debugger. It's in active development. We switched from Visual Studio to Remedy when Visual Studio refused to launch. And we've had no worries with it. So far, it's been working great. So, hey, I think we may be done with Visual Studio. I think Visual Studio, we may be able to take it out back behind the tool shed and put a bullet in the head and good riddance to bad rubbish. So thank you very much to George Manhorn for all his work on Remedy. It'd be pretty nice to never have to load Visual Studio again and all that implies. But who knows? It's still early in Remedy's life cycle, so we're not asking for a miracle here. So there may still be some rough patches ahead, and that's totally fine. It's a brand new debugger, so you got to cut it some slack. But so far, it's been real good. Kudos to George for all of that. Right now, we are in a sort of testing position. Now we've got, as far as we know, we didn't really do too much with it because we sort of finished up just as time was running out last time. But if you take a look at where we're at with our Handmade Hero build, we have done all of the debugging work to ensure that we are actually importing, and we can even look at these if we go into the directory and look at the text dumps, but to ensure that we're actually importing sounds as part of our unified asset import system. If I open up tab view from the bonus pack here, intro cutscene .text, what you can see is our assets are now can include audio, and they can actually include chained audio assets. So what you can see here is like the audio gets chained out in chunks that can be read. So really long audio, like this music test piece here that go on for minutes. We don't want to have to load that whole sound in necessarily. We want to be able to stream it over time so that, our streaming system has nice bite-sized chunks worked all the time and can keep the load just like it does with bitmap assets. So that should be good. What I'm noticing here, just looking through it, this is stored more than once, which doesn't make a lot of sense, right? You can see that stored here and here. And so I'm not sure why that's happening, but that might oh, you know what? That might be because it's 2-channel. So that might be fine. Let's take a look. Channel index 1. Channel index 0. Okay. So that's just because it was stereo. So even that's fine. So I think we're good there. And then we've got all of our other stuff here. So, one of the things that I think maybe we should shoot for is let's try to play this music test over the opening cutscene. It doesn't go with the opening cutscene, so it won't sound very good. It's also just a random piano sample or something. But we can just use that as our goal for getting the audio subsystem fleshed out and finished as well. We kind of did that work to a certain extent for textures. They're working kind of more like they should now in a more shippable way. And so what we'd like to do is do that for music chunks now as well. Now, we already had music working in the game, so we don't have to do all the work of like writing a mixer and all that stuff. That's already done. But what we didn't really have is kind of a finalized way for us to do our music streaming. And I'd like to do that a little bit more cleanly now as we go. So there's a lot of ways we can approach that, but I think what I'd like to do is I'd like to keep it simple and just do it the same way for the most part that we're doing our art assets. The way that we do our art assets is they're just fixed size chunks, and we lay them out inside fixed size chunks, right? That's pretty much how it works. And the only times that we don't do stuff like that is when we have like unusual, like for example, the intro cutscenes can have unusual big plate sizes. But most everything else that's a sprite gets broken up into fixed size chunks. For audio, since it's one-dimensional, it's pretty free for us to just break these into fixed size chunks as well and say, look, let's just pick a chunk size. We sort of settled upon 256K. Let's just make a bunch of 256K chunks, and we'll just load audio into those as necessary. That seems like the best way to do it to me. We won't have that many sounds playing at a time anyway. You know, we don't have a huge budget for the AV of this game, so it's not like we're going to have like hundreds of thousands of sounds playing all the time. When you have a large budget for AV, that can actually happen. Um, so I would like to draw a little bit of distinction there, is we might want to be more creative about how we do things. If we were trying to shoot for really large numbers of sound samples playing, we would have to make concessions for that and think about that in the design. We're never going to get there on Handmade Hero. That's like only AAA games get that kind of sound attention, where there's literally hundreds of sounds playing, like all these like ambient things and all of this mixing for all of these different things. You know, we're not even going to have, you know, we'll have 1,000 sounds total or something, right? Probably in the game, because that'll be what we can afford. We're not going to have like a sound designer that gets paid hundreds of thousands of dollars a year, or a sound design team going through and adding like all of these sound effects to everything and layering everything and, you know, making these really rich soundscapes. So it's worth noting that as you get more towards the AAA sides of things, there are different concessions you have to make. You do have to start thinking about things at a more meticulous level. We'll never get there on Handmade Hero, so I think we don't want to overcomplicate that system without really knowing what those even would be. And I wouldn't recommend us doing anything differently right now anyway. I would take the same approach I take to a lot of things, which is I'd want some people to actually start producing those soundscapes first and then start attacking what looked like our weak spots based on those profiles anyway. So again, don't try to over-engineer something for use cases you don't have yet, I guess is the way I would put it. So I always would focus on the ones we actually do have, and in this case, we kind of know what that is. And it's just going to be, I think, fine to say, let's make 256K chunks. We'll make some number of those. So, you know, let's say we wanted to spend a quarter gigabyte on sound, right? If you wanted to say like, okay, we're going to do 256 times 1024 times 1024 times 1024, right? That's oops, sorry, that's not going to work. I meant that. That's a quarter gigabyte. So if you're going to do a quarter gigabyte on sound, right, then we know that that's going to be a power of 1024 over like what we had, right? So we know that we could store 1024 sound chunks at any given time if we dedicated a quarter gigabyte of the system RAM to it. And that's not very much system RAM. We could dedicate a lot more. We're not doing very much with the system RAM. We just store our world state. And most machines today have gigabytes of memory, you know, 4, 8, 16. Even consoles have something like 4 gigabytes of memory now, which is nuts when you think about back in the day. So we could even do like a whole gigabyte for sound, which would mean we'd have like 4,096 sound chunks active at any given time. Again, that seems like more than enough for what we need. So I think we should be totally fine with just doing a really basic chunk scheme. And that gets us out of the arbitrary memory management side of things as well, right? So if I pop into the asset system, what you can see here is we kind of just left some sketches in place for how audio was going to get loaded. You can see in here we've got like a renderer texture loaded at sample index and a loaded font. I'm not going to do this load at sample index. We had sketched out a way of doing things where we would like load things in at a particular sample, play them till our load meter got like past where it needed to be, and move them. I don't really know that we need to do that. We could. I mean, it's tempting to do, but I just don't know if it's wise. I just said we should just do a chunking scheme, and I feel like I should do that, but yeah. So, what do you folks want to do? I mean, what do you think we should do? Do you think we should try the crazy loaded at sample index scheme? It seems maybe a little too crazy, but I've never seen it discussed before, so that usually is an argument for doing it on Handmade Hero, because I like to draw things out and show you how we attack new problems. That's pretty much the entire point of the series. And so sometimes I like to sort of try things that I've never heard people try before, just because it seems like that encourages you to experiment and see how programmers attack problems that they don't already know how to solve. And obviously you already know how to solve the fixed size reuse case. We've done that many times in Handmade Hero in different ways. So that's something to be said. If we were going to do that, you can see here we've got a sample count and a sample buffer. The idea here, we would just set this to some large number. Let's say we set it to the 256 megabytes or gigabyte, whatever it was. We would then have a U64 that was the sample buffer base index, and that just goes up infinitely over the entire lifetime of the game. Every time we need to load a sound, we load it there, and we slide effectively the buffer base around. So we say, look, we need to load this much. We either reset back to the beginning of the buffer if we couldn't fit it, or we load it there if we could. And it's just a circular buffer that we fill. And then every sound just remembers where it was. And when the loaded base index moves past where you are, your sound is no longer loaded, and you have to load it again, right? So that's it, right? That's all it is. I don't know what sample buffer load index was. I'm not sure why you would have needed that in this scheme. In fact, I'm not really sure you do. Since we obviously already put this in place, I guess I'm going to go back on my word after literally only just saying it, and say that I maybe will try this. Can we get sample buffer base index? Did we ever do anything with that? I don't think we did. So let me go in here and see. Let me give a quick overview of this, just really quickly, because it looks like we never implemented it. I remember I said what it was. I'm just going to say what it is again for the benefit of folks who didn't actually hear that and are going to watch right now and not know what I'm doing. And so if we take a look, today's day 256. And this is the crazy sound buffer. I don't argue this is a good idea. It was just an idea, and I'd never heard it tried before, so I thought I would try it. I just made it up. It's weird. The idea is simple. You basically just say, look, I've got a certain amount of memory that I'm going to reserve for sound. So let's say it's 256 megabytes, but doesn't matter, right? This is just any number that you want to reserve. You allocate that memory. So this is 256 megabytes. I need this to be more stable. There we go. You allocate 256 megabytes of memory. Here it is. And then what you do is you say, I start loading sounds at 0. And they just fill this up. So here's sound A, here's sound B, here's sound C, here's sound D. And obviously with 256, let's say this was much lower for this example, because 256 megabytes would fit way more sounds than that, but you get the idea. I load in the sounds. When I get to the end of the buffer, at some point I'm going to ask, eventually I'm going to ask to load a sound, and that sound is going to be its sound is going to not fit, right? So it's going to have to be put, like, let's say here, because I want the sound to be contiguous. I don't want to wrap the buffer, right? And even if I could, I would need to put this part at the beginning at least. So even if you treated it as a fully circular buffer, you'd still have to use the beginning. So what happens then is you just overwrite whatever sound was in there now, and now this sound is considered evicted. So if you wanted to play sound A again, you have to load A again. That's it. The reason this is interesting is because it gets rid of any notion of any tracking at all for the sounds. You don't have to keep an LRU. You don't have to have an eviction scheme. You don't even have to have a state that says whether sound is unloaded or loaded. You just look at whatever its U64 index is, and that tells you whether it's loaded, and that's it. Right? So that feels kind of compelling, and I don't see a lot of downsides to it. The reason that you might not want to do this, the only downside I can think of, is that if you have a sound that's played all the time, like let's say there's just, the sound of like the hero like hopping. So it's going to be played all the time. So you kind of never really want to evict it. It's always going to be a sound that you want in there. This scheme will cause it to fall out and get reloaded all the time, right? Because, if you imagine you're doing like A, B, C, D, E, F, G, H, I, blah, 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 blah. If on average, let's say that the 256 megabyte buffer rolls over every 2 minutes or something, right? I don't know how many sounds we'll have and how many of them will play, so I don't know how long this is, but let's say it's 2 minutes. If it rolls over every 2 minutes, that means you're going to have to load the like glove swipe sounds and the footfall sounds every 2 minutes, right? Whereas if you had a scheme that was more intelligent, you wouldn't have to. Well, I even came up with an answer to that, and I think that's what this was meant to sort of represent, but I'm not sure we actually want it to be the way it is. But we might. There's a reason it might have been this way, and we'll see that when we go. But I'll tell you what the conceptual thing is either way. The idea was simply that, look, if you know that you have a 256 meg buffer, let's just dedicate a low range of the buffer, let's say 64 megabytes, that comes out of this. Well, it would actually be that much to scale. Let's just say there's a 64 megabyte bottom watermark, essentially. And if you go to play a sound, and that sound is in the gutter part, so that bottom part, instead of actually playing the sound, you copy the sound out into the buffer as a new sound. So you don't have to reload it, you just do a mem copy, right? So that has the effect of anybody who was getting close to being evicted from the sound buffer, but who gets used on a recent frame, does get pulled back into the active set, right? Again, I have not done any analysis of this idea. It's purely just a whimsical idea, and I don't have any arguments for or against it, really. It's just something I haven't seen tried for sound buffers, and it offers you something that a fixed chunk scheme doesn't offer you. What it offers you that a fixed chunk scheme can't is that instead of using memory paging, where you need to say, look, maybe this sound is only, 16,000 bytes, but my chunk size is 32,000 bytes. You have to figure out how to avoid that waste, right? You can pack sounds together maybe, and then hope that they get used at the same time, which is just kind of a crapshoot. You can just accept the waste and not use that space for storage, right? But inherently, you end up in a situation where you're wasting space, right? And so what this does is it says it doesn't matter, because you're always loading things into the linear buffer. You never waste any space. The only thing you're really doing is, if you want to implement this scheme, is you end up with a little wasted space when you double copy, but that space is presumably quickly filled up by new loads right away anyway. So in theory, you're really not wasting much space at all. And you can always set it to a pretty low value to sort of balance how much you do redundant loads versus how much space you waste. And then everything else in the buffer is always tightly packed, right? So anytime you're going to load, even if your sound is 32 bytes long, you're only using 32 bytes to store it. And that's totally different than most schemes where you have to work out some other thing. Either, you're doing that memory packing implicitly by letting malloc pack it for you, or you're managing it yourself and you have to do some kind of page merging. But this scheme gets rid of all of that. So it's the only thing I've ever really thought about that allows you to do optimally packed memory with no work. Like, there's no work, right? We're not merging sounds. We're not tracking lifetimes. We're not keeping a queue. We're not doing a malloc. We're not managing memory. We are literally just recording one 64-bit integer, and that's it. So I'm going to try it. I said I wasn't going to try it. I said I was going to do a simple scheme, but I'm going to try it anyway. And to be fair, this should be a very, very simple scheme. It might be a little tricky to get working because it's something I've never thought about before. And sometimes if you've never thought about something, you aren't aware of the subtleties. So there's that. But I think we're just going to say, look, we're just going to do it, and we're going to see what happens, right? Okay. So what I'd like to do here is say, in a sense, maybe, looking at this, I also do wonder, this is another, I probably won't do it now, but I think you could also get rid of the atomic compare exchange and actually just use an atomic compare exchange directly on the 64-bit offset. So you could probably also simplify the lifetime, the multi-thread lifetime understanding that we currently have. I think you could actually do that in one fell swoop, which might be another argument for using this system for sound caching. Just a thought. But anyway, so here we go. Here is our sound loading code. Here's what we're doing. We're taking the same tack as we were doing here, basically. But the begin task with memory side of things, I don't think we actually need. So begin task with memory is a thing that actually uses some allocation. And I don't actually know that we ever need that to happen. So if you look at begin task with memory, that's a thing where the tasks actually have some, like a memory arena, that they can actually use for their own allocation purposes, and then it gets cleared when the task is done. I think, and I may be wrong about this, but I think that is actually not necessary anymore. So I could be wrong about that, but I think we may be able to remove begin task with memory entirely and literally never have that be a thing anymore. So if I go ahead and do begin task with memory here, and that would simplify things for us as well, which is nice. So here's our begin task with memory call. You can see it here. I'm going to take a look at it. So in load bitmap, does it actually use the memory? I don't actually remember. So let's see here. I don't think it does. So you can see that it just uses the texture op data here. So it doesn't need, so it literally doesn't need that arena at all. And load asset work is all we would need to store in there. So it's worth noting, and I guess I don't know exactly when we would want to do this, but from what I can see, I'm just going to put a to-do in there, right? And say, I think we can now safely remove begin task with memory. I don't think it's actually going to be necessary anymore, since textures and audio both read directly into unknown location with no temp store. Now, I don't actually know that that's true. Maybe we'll find that we actually need that. So I'm not going to do the work of pulling it out now because it's in there, it works, it will work for our purpose now. There's no sense in removing a feature we already have working. It's not really a problem. It's some cost and complexity we can remove from the system later. If we then find that it never does anything for us, we might as well. But we'll leave it in for now because we don't have to remove it, right? So what we're going to do here is say, all right, we're coming through to load sound. We're going to do the atomic to make sure that we're actually sort of working with it properly. And we're going to do our load. Here is us grabbing that info out. And what you can see is when we do asset memory size, that was our old sort of way and I think that should give us an error now, right? Because I think we removed that. Did we not remove that? We still have asset memory size. Does that get used? This was when we were doing stuff before. Yeah, you can see that it's really only used for this one case, right? So we don't really need asset memory size anymore. That was when we were doing arbitrarily sized memory management and merging things and all that kind of nonsense. Now we've gotten rid of all of that. I don't really need to worry about it anymore. So we don't really need this, but we probably do still want some of these pieces of information potentially. Although now that I think about it, we probably don't really have to do any calculations because channels are now separated, so we don't load multi-channel at a time. And the size of the data is actually stored directly in the asset HHA. So this is how much we would be loading, right? I can't actually remember the exact name of that field. But inside every asset, we now actually store its footprint as an explicit value, which we always should have done. I don't know why I didn't do that, but there it is, right? So we know exactly how big this chunk is, and so I think this part is really not necessary. We know how many samples there are because we can divide. So we could say in here, actually I guess I'll do it this way. We could say the sample count is just going to be whatever this size is divided by the size of an S16 because we know we only support one sample kind. And so if I want to, I can do that pretty easily, right? I can do this. I can do this. And now we know exactly what we're dealing with here, right? So now if I say, all right, we've got, asset memory acquire, all this stuff that we used to do, none of that's necessary at all. And so we're really talking now about the much simpler version because we've gotten stuff, we've gotten out of the sort of arbitrary weirdness there. And we know that our loaded at sample index, this is the only thing that we actually need to worry about, is setting that loaded at sample index, right? Okay. So what we're going to do here is say, okay, we've got this sort of stuff we were setting up on the sound. We don't need that anymore. It's going to access that directly out of the asset structure. So that stuff doesn't have to happen. We don't need any of this nonsense where we're doing any kind of channel layout. Like all of that's gone now, right? This is much better and simpler. So when we actually set this up and we say, okay, here's the task, here's the asset, here's the file handle, here's the offset, here's the size. Again, that's this. You can probably just not do any of this. Well, I guess we do need that one thing there. Well, I'll just get it out of work size, probably. So I think all of that goes away, and we're literally just looking at this. When we go for destination, that's the one place now that we actually have some work to think about doing, right? And there is a subtlety here. I'm not sure it's a subtlety we actually have to worry about. I think I'll talk about it after I'm done because it's fairly it's how do I want to say this? So there is something we could choose to guard against, or we could not choose to guard against it. And it's the kind of thing where the worst case scenario is you get some corrupted sound playback where it plays back one sound instead of a different sound. I will explain that later if I don't. Remind me in the Q&A. I probably just won't guard against it. It wouldn't cause a crash or anything like that, which is yet another reason why this scheme is kind of attractive. And I just don't think it will ever happen in practice because in order for it to happen, you would have to have like a catastrophic OS failure, which isn't something that's out of the question, but I just don't think it would be worth the complexity to guard against it because who cares? I just don't think it will ever happen, and if it does, the worst case scenario is you play a bit of the wrong sound. But it's always worth knowing, right? Like, it's better to know when something could happen and document it. You don't want to just say, that'll never happen, and then, move on. Like think it through, or at least know that it's, get it in your head, do the thinking through, know that you've got these cases and document them, or at least be aware of them in your head. Don't just not think about it, right? I mean, might be the way to say it. So anyway, as you can see, literally all the stuff we need to do our asset work is here, except for one thing, which is where exactly we want to put this thing. And like I said, really all we have to do for that is to go, well, we've got a sample buffer. We know it can contain however many samples are here. We know this is the base index off of it. And so what we should be able to do now is say, what's the actual sample index? So what's the sample buffer index out of all of these, right? And to a certain extent, when I'm looking at this, what I'm seeing, this doesn't really make a lot of sense to me, because what I'm seeing here is I'm like, why do I care about samples, right? This is just a buffer. If we eventually wanted to load sound samples that were 24-bit or something, it would just work. So I think what I'd rather do is say more like that, and say, look, we're going to have a sample buffer, and it's going to have some amount of data in it, but I don't care or know how much, what the type sizes of samples are. If you wanted to load some 8-bit samples, or some 24-bit samples, or some 32-bit samples in there in some kind of weird mod to Handmade Hero, this scheme just supports that fine. So let's stop talking about samples when we're loading, and let's just talk about the bytes, right? So then what I'd say is, okay, we've got a sample buffer base, and this is, I guess, really like a position. It's or an offset. It's I don't know. I mean, I guess index maybe is the best term. I'm not sure. But the reason that I'm shying away from calling it a byte is because this is actually just a monotonically increasing 64-bit value that never gets smaller. And it doesn't index into this buffer. You have to mod it first to do so. And so what we want to do is take this sample buffer index here that's coming off of the assets, and we want to mod it into our actual ring. So what we're doing is we're saying, look, do a divide here and tell me where in the buffer I would be if I was to load at the current base index, right? So what I want to do there is I'm just saying, look, this value goes up forever. I want to assume that it's mapped in a circular fashion into this tiny buffer that I've got. Tiny being 256 megabytes, which is actually huge, but not compared to a 64-bit number, right? Map it into this rotating buffer and tell me where I would be in the buffer for all the revolutions that I maybe have done, right? So this mod can really, if we want to make this be a known value, it could just be an and, right? And so in some sense, we could make this be something that's set at compile time. But at the moment, I'm not going to do that because this mod happens almost never. And so it really isn't the kind of thing that we would care about in that way, right? So I think we don't have to worry, but if we wanted to, we could speed this up by making this be something that's less expensive than a mod. Nowadays, I'll be honest with you, don't really know how much that does cost. Kind of interested to know. One thing that I don't know if we've actually ever looked at on the stream is Agnarfog's instruction tables. I might say let's get those on the desktop. I use them a lot more now than I used to, and they're kind of fun. So if you look up Agnarfog, it's his programmer. I know that's probably a name that's unfamiliar to people who are maybe used to U.S. names or stuff like that, right? Like it's not a name that you may have heard as a common name in use. But that's just a person's name, Agnarfog. I don't know how you pronounce it. I've never heard it said. But he did a lot of work with basically taking x64 and x86 CPUs and figuring out what the actual timings are for like various instructions, things like that. He publishes a guide. It's pretty good. Sometimes it's inaccurate, but a lot of times it is accurate. And it's good for getting a rough estimate of things. So look up Agner Fogg's instruction tables if you want that. I do want that. And if we go to our desktop now, we've got it on there. I'm going to call it Agner Fogg instruction table so we know what it is. If we load this up here, what we can do is it's broken down by processor. So if we go to the processor family that we're on here, which is like Skylake and Skylake X, if you look at the section on Skylake, what you can see is just a giant set of tables that tells you all sorts of things, like how many cycles things take for throughput and latency and so on, right? Now, there's a lot of other stuff in here that's actually really good to know. And for example, this port, which tells you which ports of the processor an instruction can execute on, is pretty awesome too. It even tells you if something's going to execute on multiple ports. It tells you them broken down. So for example, here's a MOV instruction. This is a MOV instruction that goes between a register and memory in this case, right? The R8L, I believe, is the low 8 bits of a register, I think is what that means. Actually, I don't really know. I almost never read the R8 side of things. But like R32, R64, right? 32-bit register, 64 bits of the register. Because you know how Intel registers are 64 bits for the general registers, but you can address 32, 16, or 8, right? And so that's what that's really telling you. If you look here, you can see for like this MOV instruction, doing that 16-bit load from a memory location takes either port 2 or 3. That's what that means. It can issue on either. So it'll take either port 2 or 3, which is basically saying this execution resource, right? There's like 0 through 6, I think, or is 7? Yeah, 0 through 7. It'll take either one of those ports it needs, and then also one of these arithmetic ports, 0, 1, 5, 6. Those are ports that actually do work. 2 and 3 are ports that do like memory load. Well, you can see it right here, right? And we can go into this in greater detail later. I'm giving you the real glossy version. But if you remember when we went over the basic structure of an x64 processor, it's got like the instruction decoding and caching and that sort of stuff into micro-ops. Then it's got ports that can issue micro-ops, and each one of those micro-op ports can do certain kinds of operations but not others. So you can see here, I need one of the load ports because it's coming from memory, right? Memory. I need a load port. But then if I'm supposed to be taking part of a register, I oftentimes also need an arithmetic port because it's going to like mask it to zeros or something, or do something else that requires one of these, right? Anyway, all of this information is great because it can give you some ballpark ideas of what you're actually doing and how the processor is going to struggle with it, like what ways it's going to have to operate in order to get the job done, and that can help you understand the performance of your routines, and it's really kind of nice. Anyway, so what I was saying is, if we want to look up integer mod, which actually I have no idea. I don't think I've ever looked that up. So I actually don't know what the speed is of integer mod. And I have no idea what the instruction is. I've never written it myself. Let me see what it's called. Do they have that in here? Another possibility is it doesn't have it. You have to implement it yourself with a divide. So I'm not sure which one you have to do. Right, because if you do an integer divide and then subtract, that's a mod. So I don't actually know if it even does that natively. Here's what I will say. Rather than belabor this point, because this is really not what we're trying to do here. If you look at what we're actually doing, you can see that it's like a 36 cycle operation to do a div 64-bit wide, right? And so, you know, you can see the reciprocal throughput and the latency here. It can be quite high, right? There's up to an 88 cycle delay for that. This is how many micro-ops it takes, right? And some of those micro-ops, it looks like could spend more than a cycle doing their job, because you can go from the micro-op number out to a much larger number, right? So I don't actually, yeah, I mean, you look at how expensive a div is, that's pretty vicious, right? So just looking at that kind of dissuades me a little bit from using it. So I think I will go the full pull and actually do, like, thank you, Agner, that gave me the information I wanted. I think I will go ahead and say, we're not going to talk about sample buffer size per se. What we're going to say is we've got a mask, right? So we've got a sample buffer mapping mask, right? And what the sample buffer mapping mask does is it says, look, let's go ahead and take whatever it is that we're doing here, and we're going to mask the incoming value against it. And we just assume that someone has built a mask that will turn this in to a 32-bit value that's inside the buffer, right? And what we know is modulus, right, is an arbitrary operation that allows us to map to any range. But if that range was a power of 2, then and modulus are equivalent, right? Because with a power of 2, the remainder will just be whatever the bottom bits were, right? So this just says, look, when you create your sample buffer size, we don't care what it is, but it better be a power of 2. And then when we do the and, this just works, right? So good by Agner. Thank you very much for telling me that modulus just looked too expensive. We should double check that there isn't a special purpose instruction for modulus, but if a divide takes that long, I would expect a modulus to take that long. That's just too long for me. I don't like sticking something in there that could take up to 88 cycles. That's a lot of cycles. That's almost getting up towards memory access penalty range. It's not quite, it could be a couple hundred cycles for a memory access penalty, but it's well over any of the L caches. So well over the cost of an L2 or L3 hit, I believe. Although L3, I don't know what the L3 cache penalty is these days. L2 is way faster than that. It's like 16 cycles or something, isn't it? I don't remember what it is, but it's pretty darn low. So anyway, yeah, what's the L2 cache? What's the L2 cache speed? Do we have that? So 11 cycles in some cases, it says. So really fast, right? I mean, so if you look here, right, here's all some estimated latencies in Skylake for the cache. So even if you miss the L2 cache and have to hit the L3 cache, it's still faster than a mod, right? Is that right? Oh, there it is. I'm like, it can't be 42 cycles. And then I'm like, oh yeah, there's the 51 nanoseconds. Like, the wires are long, my friends. Okay, so if you look at this, it's just, I was uncomfortable with the fact that that mod takes as long as a memory miss out to anything other than main memory. So even out to L3 cache, that's just no good. So I'm going to do it this way and use an actual and there to make sure that we're not having to do a real modulus there. That's just bad. So here we get our sample buffer index back. Now we know that we're going to load into the sample buffer at that location. But what we don't know is, will it fit? So what I do need to do now is say, look, what was the data size, right? Because here it is. And I'm going to go ahead and pull that out like I was wanting to do before. So there's our data size, and we'll just chunk that in here. And what I'm going to say is, if the sample buffer index plus the data size is greater than however big the buffer actually is, right? Meaning we would overflow. Then we have to wrap. So what we need to do then is say, look, whatever the sample buffer base index is, needs to move up to the next boundary. And then our offset's going to be 0. So our sample buffer index here will become 0. We're going to load, we've gone off the end. We're going to load at the bottom. And our sample buffer base index at that point needs to move up to the next, the next even multiple of that value, right? So much like here we were doing this and off, right? What we want to do now is take this sample buffer base index, which we now know is, needs to get moved one up. We know that our data size is enough to do it. So it seems to me like it's probably sufficient to just say, look, let's take whatever the sample buffer base index is, let's load, pretend we loaded this at the location, which we know pushes us over the boundary because we just checked. And then let's and off that part that we had before. So this mask, let's say and it off just like we were doing before, but what just happened? Why did that not copy? Copy. There we go. I don't know what was going on there. Something weird. But so let's go ahead and take what we now have and off that bottom part by saying whatever the mask was, normally this ands off the top. So if we not this, right, if we take the inverse, that should and off the bottom, which is what we want to do to get rid of any fractional offset. So this just basically recenters us to the bottom of the buffer, right? So that should completely solve our problem, I think. Meaning now we just loaded the thing in, we've done the sample buffer size check, we've figured out where we're going to load it, and now creating our destination is trivial. It's just whatever the sample buffer is in that sort of sample buffer size there. Whatever the sample buffer actually is, we're just going to take whatever the sample buffer index that we computed, we're just going to offset by that much, right? Now, once we've done that, which we've saved here, this also now needs to go up by the actual data size. So in addition to doing this add there, which we know recenters us, we also have to load as much as we were going to load, right? But we need to do that in either case. So the base index, after we compute which one we're going to use, we have to add however much of our data we actually loaded. We have to add that much in so we don't use that part anymore, right? So I think that gives us our entire load. That loads our sounds now. This has to be sample buffer size. There we go. And the finalize operation, I think we may have gotten rid of. Is that true? Because nobody actually needs finalization anymore. So that's just gone. Yeah. So what you can see here, again, unless I'm missing something, this is why I say this scheme was interesting. It's so simple. This is the entirety of the code necessary to do your LRU, your variable size loading, your streaming, your everything. That's it. That was it, right? And the only thing we need to do now to add like sort of a least recently used modifier to it is just add one memcopy when we actually go to load a sound, or to play a sound, if we so desire. Now we don't even have to do that, but I think I would like to minimize the chances that we hit a sound that we already had loaded and that fell out because we just weren't tracking the fact that we were playing it a lot. So what I want to do here is say, look, really all this thing needed after all of this nonsense, all it really needs, right, is this value. So what I'd rather do here is have an actual thing that's like, hey, yeah, maybe there's a void star that's like allocate or reserve sound memory. And what I'd like to do is say, I just pass that a size, and it will do this. So it basically says, all of that is something we can call as necessary. We just call reserve sound memory, and we pass the data size here. like so. And that way, that's something we can do in the other routine, in the playback routine as well, so we never have to rewrite that. Which again gets us to the point where I'm like saying that's the entirety of the code you have to write, which is kind of cool. So this reserve sound memory basically says, look, take the assets, take the data size, get this stuff aligned properly, do all that. And if there's bugs in here, this is good because it means we only have to debug them once, right? So let's load this out just for clarity. There's that mask. Oops. Didn't mean to expand the console there. So this just becomes an and with the mask. This becomes an and with not the mask. Just makes this a little easier to read, right? And I think that's all we really need to do. That all seems good. So now to produce the actual result we want, we have a void star result. We're going to take the asset sample buffer. Just called sample buffer, right? And then we're going to add that sample buffer index to it. Having a lot of problems typing today. Not a good typing day for some reason. I think maybe the keyboard is off center. Let's get that there. That should be able to take care of both our load sound call and when we do playback, it should also work. So I think we're good to go. And I just want to take a look at where sound playback is happening here. So this, get sound samples, that's really what we would need to do the playback here. And so this is the place where we would do any of that sort of adjustment work, right? So I think all I need to do to make this thing complete is just say, well, you know, if this sound is loaded, and so, you know, when we do the get bitmap info, get bitmap here, what we need to do is look and see whether or not the actual sound is valid. So if in here we do get sound samples, what we would need to do is actually ask, and by the way, is this, where do we ask to load it? So I guess it's in load sound that happens. Here's load sound, which is the thing we just did. So I guess that's all fine. So I guess the sound loader will just do it. Seems fine. So all we really need to do here is we need to say, look, we need to get that that asset, right? So this asset that we've you know, sort of looked up here. We need to look at what its loaded sound index is. So we need to say that value that we should have set. Oh, you know what? We're not actually setting it though either, are we? So I guess this is a little bit off because we actually need two values when we do reserve sound memory. We actually need to set on the sound where it went, and we don't have that right now. And we do have the asset here, so we can set it here, right? So what we would want to do there is we want to look to see whether this thing is loaded. And so I think what we want to do is say, look, if, you know, this asset, if its state is asset state loaded, then we'll give it back to you, but otherwise we won't. Now, we don't technically have to do that, but the reason that I'd like to make sure that we do is because we want to make sure that you don't try to play a sound back that hasn't actually been loaded yet. If you want to play a sound back that has been unloaded, that will actually get caught by the next check. So that part we don't really have to worry about. But the other thing where we haven't finished the load yet, we do need to check for. So this wants to look and see, hey, make sure that someone set this to loaded at some point, right? So then what we're going to do is say, okay, if the asset, there's the sound. If the asset's loaded at sample index is greater or equal to the asset's basically high watermark, So in other words, if we have reason to believe that this thing could actually be run, right? And that is right here, right? So if this thing is above where we said the base was going to be, that's the loading point though. So we actually need to be back by that much. So we actually need... So that's really a bad name. That's actually a sound buffer top. We should really call this sound buffer end index. Do you know what I'm saying to you? I feel like it should actually be that. So what you're actually doing is saying, look, the base index is whatever the top of this buffer is minus the size, right? Does that make sense? So we kind of know that there are two sound ranges, if you will. And in fact, we could make those systemic. We could say struct sound buffer or like asset sound buffer ranges or something like this, right? And what we could do there is say, look, give us back the sound buffer base index and give us back the sound buffer, I don't know what we want to call this, but like LRU index. So like that thing where I was saying I want like a region where we'll maybe consider a copy out if you fall inside it. Give me back that one too. So here I would do something like ranges equals get sound buffer ranges and pass the assets. I'm going to assume that will compute this for me. I will then say, look, if the asset is in range, that's great. So let's say ranges dot sound buffer base index. If it's above the base, we know it's loaded and we can play it. That's great. But we probably, and I guess we don't really need an else case here. What we really need is another case here. This result will default to 0, so if we don't need a catch-all for that. So first we want to actually check whether or not it's above the LRU. If it's above the LRU, we're just done. So we could just say wherever the sound is, that's what we would load, right? So here is just a, I guess I might do get sound buffer pointer, maybe? And I just say, great. Let's load that in, and I'm going to pull this out into a temporary so I don't have to keep typing asset arrow, so it's clearer there. Right. So great, give that to me. If, on the other hand, we're in the low region, so this case would be we're not above the LRU watermark, so we actually want to do a copy. Here's where you would do that copy. So we would call reserve in this case, and that reserve is up here somewhere. Reserve sound memory, right? I'm going to add this one in there too. So this get sound buffer ranges. So that'll just be asset sound buffer ranges result. And this will return these two values by computing them. Oops. So we will need to do that in a second. That's really an easy routine to write, so that should be no biggie. And then we also kind of want the get sound buffer memory call. So this is void star. And that takes a U64. There we go. So that all seems pretty good. I'm happy with all that. So then what I'm going to do here is say, all right, we'll implement these two routines in a second. And then what we need to do is say, in the case where we want to do our LRU scheme, what we're going to have to do is do a reserve where we actually, get more space for this. And then we're going to actually move it from one place to another, right? So what we need to do is figure out how big the sound is. Again, that's really no biggie because it says exactly what it is in the size field. So there's our size. And then we're just going to use that as the copy. So here we have our, our desk pointer basically. And our source pointer is always going to be this get sound buffer memory call because that's where the sound was regardless. So, we're going to get where it was. We're going to get where it should be now. And we're just going to move it, right? We're just going to move it up. Now, we have an issue that's kind of tricky. Yeah, so I think this can never happen, so it's okay. I was going to say if we ever ended up with these regions overlapping, but they can't. As long as the size of the maximum sound chunk is never bigger than half the buffer, you can never have this happen, so it doesn't matter. So this is not relevant. So I'm pretty sure this will always work. You can just say, look, copy the memory from the place that's going out of scope into a place that would now be in scope most recently, and call it a day. Wait, is that true? I'm just thinking this has to be aware of overlap. Let's draw the case out, shall we? Because I'm just not sure. Okay, so here's what I'm talking about. Effectively, what I'm saying is we have some part, and it could be anywhere, right? But we've got some kind of a pointer, right? Which is this is the top. And then this is inside the circular buffer. And the sound is like here. So here's sound A, right? And what we're basically saying is that this region is the LRU region. Which means in this region, if we have a sound that plays while it's here, we want to move it out because it's going to be evicted soon. And we don't want sounds that are getting played frequently to ever be in here because it's going to get evicted. So what I'm saying is that, well, in this case, and I think I'm right, in this case, these regions will overlap. So the new location for A, which will then move top above it, so it'll be right here, the new location for A will be compacted down and part of it will overlap. Since copy proceeds from the low bytes on, I think we have no issue. It's never going to look the other way, meaning we're always, I think, copying it either to disparate regions that don't overlap or in regions that only overlap the end of the destination with the beginning of the source, and that should be fine. Famous last words, but I think the simple thing just works. Let's hope so, because my claim that this is a simple algorithm starts to fall apart if all of a sudden you don't have the simple thing work, but oh well. So I think this is all we need, and now we just need to implement these. We do have one thing we wanted to do here in order to track that loaded at sample index. That loaded at sample index really shouldn't be called that anymore, right? This should just be called load at buffer load at sound buffer index, right? It is not a sample. It is not a sample. We are just using byte offsets there. So it's just an index into the buffer. It has nothing to do with samples. So what I'm doing here is saying this is going to be a asset or a sound buffer memory that you get back. We're going to have the pointer to the memory, and we're going to have the the buffer index to the memory come back. And again, this is just because when we do this in the sound buffer memory case, when we call get sound buffer memory or reserve sound buffer memory, what we want to be able to do there is actually return a more complex piece of data. So in both cases, when we call this, we need this result to give us back two things. First of all, the pointer, which we know we can get at all times this way, right? But in addition, we need whatever the index was that we were going to feed into the buffer, right? And we are not actually getting that yet. So what we need to do here is save before we advance, right? We need to save what that index would have been. So this value before incrementing, right? So here we snap both of those things. So this is where the sound was, right? And that's something we wanted. And then we also have the pointer. Now, if we want to be squinky about it, we could always get it from get sound buffer memory. Instead, what I'm going to do is actually probably just assert that fact. So because we already know it, I'm just going to assert that result pointer equals the get sound buffer memory of the buffer index. So I'm just going to assert that they never diverge and call it a day. In this routine, we have the same thing. So we've got loaded at, we've got assets, sample buffer. And what we just want to do here is take whatever the base is of the sample buffer, and we just want to load in the version of this that's got modded to the mask, right? So basically, you know, chop off that top part, put it to where it should be, and off we go, right? What I'd also like to do here is maybe do an assertion. So when we get back, whatever this pointer is that we've sort of received here, what we probably also want to do is assert that the sound actually would fit in there. So one thing we could do here is say also assert that if we were to cast this to a U8, that result pointer minus so that result pointer plus the data size, right, is not going to be over the total size of the buffer. So this sample buffer size plus the sample buffer, right? So this must be less than or equal to this. And that's just to double check our arithmetic. Like, we want to make sure that the thing we return, it never returns a pointer that couldn't actually fit the size that you asked for. Because, you know, based on the way we allocate memory, it may be that we could do that and never know, and we'd be loading off the end of a buffer and never know. So we want to make sure that we, like, check that buffer math there, and make sure that whenever we give one of these things back, we don't do it something where we've actually not left the room that you know, we've asked for, right? So I think that's mostly what we want in terms of those functions. And so now when we call reserve sound memory there, like this, we'd actually pull that out. And so we'd say sound memory, or, you know, just maybe just memory equals this call. This takes the pointer, and the sound now gets that loaded at buffer index, or sound buffer index. That gets the buffer index, right? So now we've set it properly. If we compile, we should get an error down below where we want to do the exact same thing but haven't done it yet. Oh, and we should make those work as well. But the one I actually wanted to talk about right now was this one. So here we want to get, again, we want to do the same thing. So that's sound buffer memory, this right here. We want to be able to call that, and this will beget the pointer. And the asset, right, oops, the asset loaded at sound buffer index will get the buffer index, like so, right? So that seems good. Now these parts here where we're creating these should be pretty easy to do. And also all of this stuff here where we were like sample buffer base index, that's actually sample buffer top index now. because like I said, that value isn't the base of the buffer, it's the top of the buffer base, you know, the top of the used region. I don't know how, it's not a great word, either one. They're both kind of wrong, but top is less wrong than bottom, maybe. I don't know if that's really true, but anyway, so in here, if we, oops, the size was supposed to be asset HHA data size. There we go. I think that's all good. Yeah. So, okay. Now we just have loaded at sound buffer index. So this is the buffer index here. I think that's all good. And the only thing I'm not sure about, looks like there was an error there. I'm not sure what it is. What is the problem? So I assume that reserve sound memory, it doesn't really know what that is. Oh no, it just doesn't know what data size is. So that just has to go up there. Okay, so I think that's a full sketch of the routine. These are computed off of the top. So if you just go to the top index here, which should be this. So the base index is always just the top index, you know, minus some number, right? So it's whatever the, in this case, the sample buffer size is. That gets you down to the bottom of the buffer, right? And the LRU rate is just that plus something. So I don't know what we want to set that to, but it can just be a size like sample buffer LRU range or something. And that just gets added on, and that's it. But that's all there is to it. So I think that's all we really want to do. I don't think there's anything else particularly squinky going on here. I think that's it. And so, yeah, that should pretty much do it. Make sure we've cleaned up our errors here. So I think the only thing we need to do to get things started is in the actual allocation, you know, the part of things where we actually get things started here. My recollection is we don't do anything with sounds at the moment, right? So if I were to search for this sample buffer, I don't think anyone actually sets it up, right? So, you know, we did all our work here and that's great, but, you know, yeah, you can see this is it. It's just these routines here. Nobody actually creates anything useful there. So what I want to do there is say, all right, let's do like init sound memory here. And let's pass the game assets in there, and like whatever the cursor, oh, that's my internal name for things is cursor usually. So we actually want memory arena, I think is what we call them here, yeah. So let's take the memory arena there, and we'll say, here's where the memory comes from, right? And then we'll just expect this thing to set that up. And so what it'll do is probably take the sample buffer size. Actually, I don't even know if I want to do that. So what we're going to do here is say, look, the sample buffer size is going to be a power 2, right? So it's going to be like 1024 times 1024 times what? Like 256, I think we said. Something like that. So maybe that's what the size of the sample buffer is. I don't know what the size of the sample buffer should be, but let's just say that's what it is. So then what I'm going to do is say, all right, let's go ahead and allocate that memory off of this arena. Now, you could argue that this should just be its own separate memory pool that just gets allocated not on an arena, but you know, that's a separate story, and I'm not really going to think about that. So what I want to do instead is just say, look, let's do a push size of the sample buffer size off of this arena, and that's going to be the memory in question, right? So this gives us our sample buffer size, and maybe I will also record the size here since we need that. And then what I need to do is make the mapping mask. So if I do the assets sample buffer mapping mask, all of this stuff, and I'm going to put that down below because these are all like derived values, right? So the sample buffer mapping mask is just going to be a loft up of the sample buffer size, and then I'm just going to subtract 1, right? So in 64-bit math, if I just subtract 1, that'll get me just that bottom mask because it'll knock out all the other bits. So that's all I need. Then if I go in and set the remaining values, the top index and the LRU range, I don't know what we want to call it. Maybe we'll call it like the bottom 16 megs. Will just be the place that we'll move stuff out of as necessary. And then the sample buffer top index. So, you could set that to 0, but what you have to remember is we're pretending that's the top of loaded things. I would rather have it start out at the sample buffer size so that the whole buffer, like that whole first swap of things, I would like it to be so that 0 is out of the range. So one way to do it maybe would be to say we're going to start loading it like 2 times the sample buffer size. Because this can be anything we want, right? It's a 64-bit value that goes on forever. So what I'd rather do is I'd rather have 0. So if you just had a 0, something that was initialized to 0, and you never really like looked at it or what it's doing, I would rather have 0 just be out of the range, way out of the range, so it's totally clear that 0 isn't a valid thing ever, so that anyone who has something set to 0 knows that their crap is not in the range. Whereas if I actually had the sample buffer be less than or equal to sample buffer size, 0 would still think it was loaded, right? And so we don't really need to do this because we're tracking loaded as a separate parameter. But imagine a future where we decide to get rid of that which we might want to do that and just track that one value. Because I think we can do everything with just that one value. I may want to try doing that someday. I don't want this to come back to bite me. So I'm just going to say, look, let's just take that window, move it up so that no sounds that have a 0 value ever could at any time during the run of the program until the heat death of the universe could never think they were loaded. And so that's what that tries to accomplish there. So that's what I think we want to try. I'm going to go ahead and go to the init call here and say that when we allocate the game assets here, the non-restored memory is going to be, I think, where we want to get this out of. So I'm just going to go ahead and say let's init the sound memory like right off the bat because it doesn't really depend on anything, I don't think. And we'll allocate the arena there, and I think we're done with that. And I think we're good to go. Now, in order to start testing this stuff, we need to actually play some sounds. We need to have some sounds doing something. And so I think we actually turn sound off here, if I remember correctly. I actually don't really remember what we did with sound. Because it's all like it was all implemented and stuff in here, but I just don't remember like when we decided to do. I thought we turned it off so it wouldn't play while we were doing stuff, but I just don't remember. I don't. I don't remember if we turned this off or if it's still going. So, are we still doing sound? This is it. So it doesn't look like any of this got nerfed. Okay, I say. hesitantly. It looks like no one literally ever calls play sound. So I guess we just start calling that? I mean, I don't know. It's been so long, I just don't remember. I guess we didn't nerf it. I guess we're just not playing anything. I'm going to look and see about the audio state. I mean, here it is, right? And we even have a music thing there. And so, I don't know, like... oops, did I do something bad there? I don't think so. So if I go ahead and do music... Doesn't look like we ever did anything with that either. Yeah, so I don't know. I guess I don't really know what's going on here. So we're just going to have to make it up as we go along. It looks like all of the code's still in place, and it looks like maybe the reason that we're not getting anything in terms of music there is just because we stopped... We like deleted any calls that would have played it. I mean, I don't know what else to say. I don't see any other nerfing. Like the audio states getting initialized. It looks like we left it all in. So I guess the only thing we did is like stop calling it, right? And so if I compile this back in, right, my assumption is that yeah, like we could just make this work pretty trivially here. The actual code to call like the play sound on it, we need to be able to get that sound. So if we look back at like the asset calls for like load sound or get sound samples, right? I don't really know. So the audio system as it stands, presumably you ask for a handle to one of those. Yeah. So presumably, you know, you would just do something where you would say play sound on this thing. So I would do something like, you know, if game state music wasn't set up yet, I would set it up. So I would say game state music equals play sound. Like so, and the audio state is just the one from here, and the sound ID is one that I would have to, you know, get, right? So I'd have to do a search for that sound ID by doing like a get asset call. So if I actually look at, you know, the get asset call here, or the get sound asset, get asset call, get best, it's like get best match, right? Get first asset from, get best match asset from, right? So if I did this, I guess what I want to do is say, and is there a get best match sound? Yeah, there is. So what I want to do is I just want to say, look, get me the best match sound from the assets. I'm going to give you a type ID for the category, which I'll have to look up what we even said those were, because I don't know that we really, I don't know that we really have many. I think it might just be audio. I don't even think we have categories for those. I think they all go in here now. So it'd be more like that, right? And then I've got an asset vector match and an asset vector weight. And again, we're going to redo that part pretty soon because we're almost done with all of our asset system stuff. So the way we do matching and store and like quick searches on matches is going to have to change pretty soon because we will die in search land if we don't. But for the moment, we're fine. For testing purposes, we're fine. So we just need a way to look one up. which we can do here. And then we need ways to play it, which we can do here. So I'm going to make, like, let's say channel 0 ID there. And in order to match this, we just need a way to like load this thing. And so what I want to do is I want to look back at what that music was tagged. So I just want to look at the actual tag file, right? So what I want there is to say, okay, in Handmade tags, I know in here I think we put the tags for it. So it's just tagged title screen and it's audio state, right? So basically, like, I should just be able to do tag title screen equals 1, tag title screen equals 1, right? Match that. And in the weight vector E, I also want tag channel. So I want to match that properly. And, you know, we could later load the other one. So here on match channel index, I could change that to channel 1, and I should get back the channel 1 instead, right? I think that would load everything that we wanted to load and go from there. So, oops, that's not supposed to say vector. It's supposed to say weight. I think that's really all we need. This stuff here, I don't really remember much about the way that this input stuff was working, so I'm just going to look really quickly at what we changed that to. We should be able to do basically the same thing. If you look in here under game input, you can see that there's like a clip space mouse P. I think that means you don't need the buffer width anymore. So I'm pretty sure what we could do here is just do a clamp on this. So we could say like music volume. I guess this is for 2 channels. What we could say is the music volume here is just going to be a clamp from 0 to 1. In fact, I think we can just do clamp 0, 1 of whatever the clip space mouse P is for the x-axis. Right. I think that's all we would need there. So that's actually simpler than it used to be. Oh, and that's from the input. So now we just have a bunch of debugging to do. I don't think we have much more to think about. Maybe we do. Maybe I missed something, but I don't know. So I'm just gonna, okay. So it sounds like to me it all worked great up until it had to do streaming, and it looks like the streaming didn't work properly. But hey, good on us. We actually got quite a bit. Can you hear that? Yeah. So we don't really know exactly what's going on there, but the first thing to probably look at is we're going to want to go see how that streaming stuff is working. And we have to go make sure that you know, it properly loads the next chunks, and then we probably got them marked up and all that other sort of stuff, right? So let's just go do some due diligence on that. I don't know that we'll have time to get that working today, but hey, that was pretty great. Everything just worked. I heard sound and it was playing, and I could even change the volume by moving the X. I mean, could change the channel balance by moving the X, which is exactly what we tried to do there. And all that good stuff. So let's go into audio and see what's supposed to happen when we're doing streaming. So here's output playing sounds. You can see the code. And in here, what it's doing is it's kind of looping over each one. And it's getting the sound samples for those, which is that function we just wrote, right? And it's looking and saying, okay, here's like the sound info for the sound we're talking about. Here's the one that would come next, which we can go look at this code to make sure it's getting the right value there. And then it's also doing a prefetch on that next one in case it needs to, you know, so it will be pulled in quickly. So we may want that prefetch to actually, well, let me set that.
So we may want prefetch to do the same move. Um,
this move. You know what I'm saying? We may want prefetch to do that if the sound is loaded. Uh, so I think, I don't know. I'm just gonna say make it a to-do. Right? So I'm literally just going to call here get sound samples to force that to happen. Right? And that way it will move it out of the eviction region if it was going to be evicted soon. And so that way, if you're telling it to prefetch a sound, it will make sure it's prefetched into the upper region, not the eviction region, which I think is what we would want, because if someone's specifically telling you I'm going to need this sound, we probably want that to be the way that it works. Don't actually know that that's true, but it just seems intuitively correct to me. All right. So we say get next sound in chain, blah, blah, blah. We do like the sample chunk here. If you use the 1.9F version, gonna be honest, don't know what 1.9F is. Oh, that. So that looks like a bug we've gotten here we should fix. Should probably tighten up some of this code just in general. So how do we know? How do we know when to use next sound in chain here? There's the volume computation. Seconds per sample times plays current sample, playing sound D-sample, samples played, total chunks to mix. Real chunks remaining sound, low sound sample count. So this is wrong. I think. In fact, I know. So the problem here is that loaded sound sample count is, well, so I don't actually know. So that sample count, loaded sound sample count is like, well, I guess that's right. That is how many are remaining in the sound total. But you may have to advance to the next sample position to, you may have to advance to the next asset. So I got to see where does anyone do that? So it looks like it's, yeah, so that looks like it's wrong. So I'm going to say that the sample count here is not accurate. Like the sample count has to be, so there's a couple things in here that we probably have to fix, right? And honestly, this routine looks kind of squinky for other reasons. we may want to clean this up a little bit. I'm not so sure about this. But anyway, the point is, I think this sample count is therefore wrong because this is the total number of samples. So if I do a quick search to look for sample count here, what you can see is it really uses it the entire time, and it's not correct. So the sample count for this loaded sound is actually the data size divided by the sample, the number of samples. The number of bytes, right? So this actually should look like that, right? And I'm pretty sure that's at least one issue. Also, we actually need the asset itself, and we're not getting that. We get back an HHA sound, but we actually want the whole asset in its entirety, right? So calling get sound info is not really what we want because we need that data size, I think. Yeah, because this only has the sample count, the channel count, and the chain. And I'm assuming that the channel count here doesn't do anything, right? Hoping. Yeah. So yeah, I think this needs to get the actual asset. So this needs to be like... something like that. Let's take a look. Yeah, I mean, I guess the other way we could look at it is if we need that piece of information, maybe it should come back with the get sound info. Because maybe I don't want to be accessing the asset directly. So when you say get sound info, right, and you do this thing here, maybe I just want you to get back an actual asset value, like that. You know what I mean? And so maybe what I really want you to do is this. And I don't actually know that I want, like, how often do we actually use, if I was going to just do loaded sound here, how often do we actually get an error on using some part of that that doesn't actually work, right? Cannot convert from sound to asset. Agree with that. Get sound info, get next sound in chain. That seems fine. Sample count, right. So that is not what we want either. So I think we're all good. So the sample count here, which we actually computed, which is this, that's the one we want to use. We would want to use it down here. So we would say, assert that the samples played is greater than or equal to the sample count of the loaded sound, which is this. And then we would say, subtract that amount away. And that should be fine. I think that's what we want there, but don't quote me on that. So I think, again, that routine is not fabulous. But now that we've fixed it, it correctly knows to advance. But I think we're good now. So, sound, ladies and gentlemen. I think that's everything. We'll need to test that code a little bit. I think we want to make sure that we actually have a little more visibility into it working. But I think that like literally just works now for everything. Like, I think we're just done. Getting some playback chopping there, but I'm not sure what it's from. Again, I think that might be us having to... I think that's us missing our frame rate. Right? Because we don't currently try to protect against that. Yeah, that's just a frame rate miss. Yeah, that's just a frame rate miss. All right, so I think we're good. I don't actually remember how much time we have left, but I think we're good here. So I probably don't want to do anything else right now. That was everything I wanted to do today. So I think that's all good. Let's double check, since I do have a little bit of time. Let me just double check. What do we do? I'm just wondering. If I go into... if I go into the audio code here, and you want to play a sound, but you don't want to keep a handle to the sound, how does that work? Like, did we really... I guess we really didn't do anything here. Like, what happens? So basically... It looks like we really didn't quite finish this part. I mean, we sort of did, but if you... the answer is that I guess you just... you just never manage these at all. So meaning you could call the change volume and you would actually change volume on some other sound that used a recycled handle from the one that you had. Which I suppose is fine, because if you're playing music, you should just always have not... You should always know where you're at in it. Maybe? I don't know. But just a little weird, so we probably want to maybe make that do something slightly different. But in terms of just testing out the sound stuff a little bit more, if we wanted to make it so that every time that the hero like hopped to some place or something, maybe... you know, I'd just be interested to play around with that a little bit and just make sure that that stuff works okay. So I'm not really sure how that should work. Just trying to think if I want to do anything here with that. Like, for example, right here, I don't don't know that we really do anything with the glove at the moment. But I could just make it so that that triggers a sound, I think. So for example, if here I just wanted to do this, I think you just can. So I don't know if the game state comes through here though. It does. So if I wanted to, I could just say, yeah, like, why don't we just try playing a sound here, and we'll just do a match on something. I don't know what we actually have for possibilities here, but we've got some stupid sounds in here. So, maybe we want to do like one of these, like bloop or something. So, we say like, get me a bloop sound. And then we're just going to play the bloop sound, right? So I think that would allow us to just test to make sure we can play sounds randomly. Not hearing anything there. What does the volume default to when you play a sound? It should default to on. So this did not work at all. Assuming that we actually ever imported those sounds, which I assume we did. Is that true? Take a look. Yeah, so these sounds should be imported, right? Here they are. So we should have some bloops in there, and we're not getting any bloops in there. So let's just take a look. That gives us something to debug here. So that's in Handmade Brain, and that's in Execute Brain Hero. So inside this code here, probably should have compiled in debug mode. But what happens? That is not a sound ID. Let's go ahead and real quick compile in debug mode, just so I can see what's going on. Oh, whoops, that's playing every time. I wanted it only on attack, first of all. So that should actually be here. Oh no! This is something we want to report. So if you are using Remedy, please report bugs so we can get them all. Of course, I can't actually do this, can I? Of course, I can't even report the bug. I need to set like WinDBG or something as my just-in-time debugger, because this thing's useless. I need it to not be... So I can't capture the... Awesome. So I can't capture the crash. Since it got sent to Microsoft, I'm hoping that he can get them from Microsoft. But we need to be able to save a mini dump, which we could do with WinBag, but of course Visual Studio is borked now, so it screws with us. I should set a to-do to like uninstall it and put WinBag in place for debug dumps, just so we can send Remedy debug dumps to George, which we need to be able to do, but at the moment we can't, because we couldn't Visual Studio is the only other debugger that's currently running on this machine. And so if Remedy crashes, it's the one that's going to get that fault. All right, so if I go ahead and run this now, I'm going to go into that brain call. Was it execute brain hero? I'm going to set a breakpoint down on that call, and I just want to see like what's going on because I don't actually understand what's happening there. So now we should get one. And oh, but you know what? The weight is not set to anything. I wonder if that's just, again, like our matching system is so bad right now. Maybe that's all it was. So it looks like actually, so this may be fine. Because I think we can say what the bug is. It looks like the bug is just if you try to rebuild the executable while Remedy's running still. Is that right? So here's Remedy. Let me load, kill, rebuild. We should be fine. And we are. But if instead I run here, rebuild, no crash. Let's break into the debugger. What was that called? I don't remember what that was called. Execute brain hero. Wait. Why is this not breaking? So I think there's some kind of problem with loading. Like our hot loading must break it. Is that right? Yeah, I think that's what's happening. And then in here, like if I rebuild, it looks like we were getting a crash, but now I can't repro it, so that's unfortunate. I was hoping that was a repro. Yeah, oh well. Well, I'm not really sure how to get that to repro. I was hoping we could, but I couldn't. Anyway, let's go ahead here and see if we can debug this part. So I'm going to look and see what we get back as a bloop ID. So the problem is it's not finding that sound, right? So matching on the bloop there, for whatever reason, we're not getting back any bloops at all. And so I'm just going to try and figure out like, why aren't we getting any bloops back? So if we go into get best match asset here, I'm going to try and look to see for each individual asset. I'm going to try to figure out like why it can't actually find those. So here's the tag array. I don't know if we can tell this. So can we tell this to be like an asset type tag so that we can see what the name of it is? So if I do no, doesn't look like I can do that yet. Can you do this? So it looks like it can't cast to our types, maybe. That would be a nice thing to have. I know the expression parser is supposed to have been upgraded. That might be a nice thing to look for. I don't know if X13 Pixels is with us today. He might not be. I don't see him on the chat. So probably not. But that would be another nice thing we could send. Is it'd be nice to be able to cast to an enum type so that we could know what those were offhand. So, like, because otherwise, I don't know which one 74 is, right? Um, which one of these that is. I have no idea. And I'm assuming we can't do this, right? So we'd have really no way of getting that piece of information, unfortunately. Now, what we can do is we can look at the match vector, though, right? And if we pull that out, we can actually see, like, 68 is the one in question. So I guess that means 74 is the channel, right? So 68 is the one we're actually looking for here. So let's see. Looking for 68. ID is 8. What? 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's just the basic category. So that's fine too. 67. So 67 is almost what we want. That's the music, right? So it's correct that that shouldn't match. We don't want it to come back with that. So that's actually not one that we would want to match there. And I also don't know, so what is, like, that didn't find anything, right? Yeah. So now let's look at what we're looking at. We've got ID 74. So that's that's variant, rather, right? So we don't really care about that. 8 is the basic type. 67 is title screen again? Oh, right. And it's like, sorry, that was the channel index. Yep. Okay. Yep. So it looks like audio, it looks like they're just, those assets aren't here. Like they didn't get pulled in for some reason. And I don't know what that reason would be. So if I load up tab view, are they in here? So they are not in here. So why aren't they in here? Yeah, they are definitely not in the base game HSA. So I think that's going to be our job for tomorrow. I'm not going to debug that now, but it looks like our sound playback and streaming and stuff, that's all working fine for the moment. So what we need to do tomorrow is find out what's wrong with our asset import that it's not properly triggering on those sounds in the HHT that are not there. Those are definitely in the HHT unless I'm mistaken. Maybe there's an if block around them. I don't think there is. You can see that these are commented out, but these aren't. So all of those sounds are in, right? And I assume that the sound block is working properly. Now maybe, I'll check really quickly just to make sure it's not something we can just fix right now, and then it's more complicated than that. But maybe the sound as opposed to music block isn't working. So let's go into import and let's search for sound. So if we look at the two of these things here, we've got, they both do audio, they both use channel tags. One looks in music and is audio, one looks in sound and is audio. So I don't think there should be an issue there. I can double check that they're in the right place because it's possible that they're just not there, I suppose. but I don't think so. So if I look under sources in base game sound, there they all are, right? And I assume that these are explicitly listed. So bloop00.wav, right, there it is. So there could still be, I mean, I don't know, but there could be like errors involved here that I'm not aware of, that I couldn't tell you. So that's something that we guess we could look at. I guess I'm not sure. We never really looked at what errors there might have been in the import. So, turns out we have bugs in our HHT, which I didn't know about. Should probably make those errors harder to ignore. So, what is the bug? The bug is that that's not a field. So now we're fine, although I don't know why attacked gets played repeatedly there. I don't know what the... I don't know what that... how that value is getting set repeatedly in such a fashion, because that's a little bit odd. Let's take a look at that real quick. But anyway, so that was all we really needed there. Our HHTs were just buggy, and our error reporting told us that, which was nice. But yeah, so let's go ahead and just jump back in real quickly. I might as well just fix that one last thing. So if I load Handmade Hero and go to the brain. So what was happening with that? I mean, we don't care about this. This code is garbage anyway, but... how is that getting, like, controller action key should only be down. Does that, like, not get cleared or something? Like, how is that constantly calling through there? Am I missing something? I could see it getting triggered repeatedly, and I think this was meant to prevent that. So the part where it says if the movement mode of the glove is not movement mode floating, because it's supposed to switch to movement mode attack angle swipe here, so it shouldn't be able to... right, to it should only be able to do that once. It should do that transition one time, right? So I'm not really sure how that's doing what it's doing. It seems broken, but I'm not sure. See? So I'm not sure what's going on there. Like, why is that? Is it just because it's too fast or something? Like, what happens with attack angle swipe inside the entity code? Let me just see what happens if we change this DT to something lower. Something's busted, because that should swing like really slowly, right? So this is just kind of nuts right now. Like, something is very wrong. when we come in here through movement, attack, angle, swipe, and it just doesn't seem like it's actually setting that up for anything. Is the glove... Parts glove. Yeah, I don't know. I don't know why that would be. This is code that obviously we're going to be going through when we do the actual gameplay stuff. So this is kind of meaningless, and there's not a real point to debugging it, but it just... I always get annoyed when there's something... Oh, I see. I see. So I think I understand what's going on here. So what happens is when we come up here to the glove code, we're checking to see if the movement mode is movement mode floating. And if it's not, we turn off the attack. That means we're immediately going to reset this value to floating, which is not what we wanted to do. We only want to do that if the... In fact, I guess we don't know that we ever want to do that. But we definitely don't want to do that if the glove was doing something, right? So I think what we really want to do here is say that, you know, this at least would have to be checked again. So, you know... What's the default movement mode? So, looking at this, I think this really just wants to be this. And this is not good. Like, I don't like this code at all. So I think it's, you know. There we go. That's more what we were looking for. Where's that? It's going to be back to that. Let's close this down. Oops. All right. So now we can go to the Q&A. Sorry I took a little longer than necessary. I just wanted to clean up some of that stuff. So it doesn't look like that defaulted to planted. Because now it's not floating, which is a little weird. Again, this is a hack. We'll just do it this way, I guess, for now. I really wish I could send this bug report. It wasn't running, so it looks like it happens when I rebuild when it's not running. There's something weird going on there. Maybe due to file reloading. And I'm not sure what's going on there. I'm hearing a little clicking too. So. I don't know why that goes out so far, but it's a pretty nice little punch there. Probably have to add attack soon, so we can punch these guys. Alright, so sound is basically ready to go. Yeah, let's go to Q&A. In the LRU copy path, you may have forgotten to set result. Ah, thank you. Let me check that out. We have to, like, we haven't tested the actual buffer, getting to the end of the buffer, because we don't have enough sound yet for that. So all of that code could be completely wrong. There's not very much of it, thankfully, so it won't be hard to debug when we get there, I don't think. But it's definitely not actually tested, right? Because we haven't wrapped the buffer, or at least I don't see how we could possibly have wrapped the buffer. All right, so that's in play sound, or get sound samples. So let's see. Yeah, you're right. So in here we get the destination out, but really probably we should just call that result, right? Because that's what it actually is, and that seems a little better to me. That seems good. Started a new job that has a gargantuan code base in the millions of lines of code, and it's very hard to follow what's going on. Do you have any general advice or approach to gain an understanding of what's going on in files that are part of very large code bases? Also, thanks, it's in large part to Handmade Hero that I managed to land the job. Well, that's great news. Congratulations, for starters. I guess what I would say there is... you probably want two things. I mean, first off, when you have millions of lines of code bases, they're usually garbage code bases, right? There aren't like good code bases that are millions of lines of code for kind of obvious reasons. It's very hard to scale. Like, you're unlikely to even be able to get enough good programmers to generate millions of lines of code to ever have any prayer of those lines of codes being good, you know? So when you go into a millions of lines of code base, although there might be some parts of it that are sane, most of it will be insane. And so you have to go in prepared for that, and you have to be able to take it, bit by bit. What I would recommend is you need a couple things. One, make sure you've got a debugger that you're comfortable with running, and spend time in it. Stepping through and stepping into the disaster that is that million line of code base is very important for you to get your head around it, because you kind of need to see the execution flow, and the debugger is kind of like a way to walk you through that, So you definitely want a good debugger with a good debug display, and to walk through it and be able to so you can see and spend time looking at code that you're not even trying to debug. Just use the debugger to help you figure out what's happening. And number two is try to use or switch to an editor that allows you to quickly jump to things by name. Because if you're using an editor that, for example, in 4Coder, right, if I don't know what get sound buffer memory is, I can just jump to it really quickly, and I can also do stuff like just type in sound and see all of the functions and types that have to do with sound. Get an editor or something that can do that. So whatever editor you're using, if it doesn't have good source inspection, you want to switch, because that's going to be really important. Visual Studio has a browse info thing, if you can get that working, where you can right click on something and say go to definition. Use that if that's what you're using. If you're using an external editor, make sure it's one that has source indexing built into it. If it doesn't, just switch to one that does. That's going to be really important, because you don't want to have to constantly be doing greps of your code base. It just slows you down. So get something that can do indexing well, right? Other than those two things, it's just a slog. I mean, there's not really much I can recommend. If you have a chance to have lunch with one of the senior programmers or something, ask them to sort of give you a little high level overview. That might help too. of different systems, and over time you can start to see, oh, here's how those programmers were thinking about it when they created this unholy monstrosity, you know. Um, that's about all I can say. Is there a name for that type of buffer? You mean the one I did for sound? I don't think so. Like, there's nothing like super revolutionary in it. I mean, fundamentally, it's just a circular buffer with an LRU, um, with copying out of the LRU region, or the copying out of the eviction region to create an LRU scheme. So it's not. I don't know that anyone ever A tried that before, but they might have, and B, if they did, I don't know that they would have bothered to name it. I'm not even sure what I would name it. A circular buffer with copy forwarding. Eviction preventing circular buffer. I don't know. John Carmack likes Rust. Is Rust better than C++? So I don't know. I don't know enough Rust. You know. Um, I don't think John Carmack's programming ideas align with mine particularly well, at least not these days. So I don't know that, if he thinks Rust is better than C++, and if he generally thought exactly the same as I do all the time, then I might say, well, I guess I don't need to look at it. I'll just assume that that's the conclusion I would come to. Generally speaking, most of the things that I see him talk about these days, I don't really tend to agree with, or they tend to be sort of just a different direction. So I would say I don't know. That piece of data is probably only useful for people who are thinking more in line with what he's thinking. So I don't know. One thing you could ask him is like, what are all the things he thinks are better about it, right? What I will say is that C++ is a lousy language, so it's not hard to be better than it. Might be another way to say it. So, most languages are probably better than C++ if they don't require garbage collection and allow you to do low-level pointer arithmetic. They're probably fine. And they would hopefully be better than C++, because C++ is kind of like the worst case. But most languages don't do those things, so, I'm assuming that one of the reasons people always think about Rust is because maybe it's one of the few languages that actually allows you to do those things, but I don't know. But yeah, if John Carmack has posted like a bunch of reasons he likes Rust, that might be a better way to look at it, like see if you agree with those things, On an interview, I was given a debugging task on a new piece of code. This company was actually generous enough to provide feedback on performance and said I would have done better if I had debugged more systematically. Do you have any tips on better debugging practices? Well, you've seen how I debug, so I don't have tips really beyond what I show on the stream. But, since I didn't see what you were doing, I can't really comment on it. You know what I mean? If I'd seen you debug, maybe I would have some thoughts. I'd be like, oh yeah, see, you could have, if you had first eliminated this as a source of problems, then you wouldn't have had to do this other thing, or, I don't know. Why can't we use the GF2P8 affine inverse QB instruction all the time? I don't even know what that instruction is. Is that an actual instruction? It looks like an actual instruction, meaning the construction of the instruction looks about right. I'm curious. Awesome. Now that's an instruction. Galois field affine transformation inverse computes the inverse affine transformation in the finite field GF2 to the 8. The inverse of each byte is given in the following table. I have absolutely no idea what that does. I tried to read Galois Dream one time, and I didn't get past chapter 5, I think. So if you want me to tell you what a Galois field is, I am not going to be able to do it. What I would say is I'm guessing this must be for encryption, right? I mean, is there some other use for a Galois field? What would you do with it? I'm assuming it's only really there for cryptography. Wait. The finite field with Pn elements is denoted GFP to the n and is also called the Galois field in honor of the founder of the finite field, Évariste Galois. Okay. GFP, where p is a prime number, is simply the ring of integers modulo p. That sounds just incredibly simple, though. I think I don't understand that sentence properly, because the way that doesn't sound right. This is what I was thinking of, by the way. So GF2 to the 8 for the Rindel cipher, or wait, that's how you pronounce it. Rindal, I think is how you pronounce it. So this is the one that they said they were doing. Right, in here, they're saying GF2 to the 8, right? Which is this right here. So it's 8x plus, x8 plus x4 plus x3 plus x plus 1. I'd have to read this in more detail. So I think I don't really know this part, right? The inverse affine transformation part. This is why it would have been good to get through that entire book. That is a really crazy long name for an instruction, though. Wow. So how many of these do they have? They've got Galois field multiply bytes. What do they use these for besides AES, or is it only AES? After reading about on After reading your about on your website, what does it mean to be in gaming research and development? What's your company's bread and butter? Are you basically a consultant for other game companies? No, not really. What I mean by that is that we don't. So, a game development company is a company that strictly just produces a game of the form that we already know how to do, right? So, for example, maybe you want to make a battle royale game, so probably you download the Unreal Engine and you put some art assets in it and you implement some code for like whatever the gameplay mechanics are, and there's the game. Or if you're really ambitious, you make your own engine, but it's basically just kind of like the Unreal Engine or something, and then you ship that, and that's your game, right? So at no point in that process were you trying to solve like an unsolved problem or a problem that was considered extremely hard or not super well understood. You're just shipping a game. Now that's pretty hard. So saying just ship a game is making it sound easier than it is. But you're not really trying to do anything new. You're just trying to ship something that we already understand how to do with a different spin on it, right? So, maybe it's because our Battle Royale game has giant robots in it or something, and yours doesn't, and so ours is different. But other than that, it's exactly the same game that you've already seen in terms of the engine, really, that you've seen a million times before, right? So when I say we're research and development as opposed to just development, what that means is we really will only be shipping games that have some pretty new thing in them, right? So there's something that there is no, like, you cannot clone the game by buying components on the Unity, like, plugin store or something. It just isn't possible. Like, you would need special technology that only we have in order to clone the game. So you would either have to build a clone of the technology we're building, or just you can't make our game, right? You have to make some crappy version that doesn't have the stuff in it that's unique to ours. So for our first game, which is 1935 that we're working on right now, it's got an interactive story engine that's completely different from anything you've ever seen before in many ways, and it would be completely impossible to clone without that. You could make a crappy version where the stories are lousy, or that's like a branching narrative or something that tries to kind of look like our game, but it wouldn't be anything like our game, right? So that's what research and development is. It means that there's new components to the games when they ship that literally no one has but us, right? And those things can be really big, like the interactive story thing is pretty big. Or sometimes they might be smaller, like for our next title we might do something smaller that's more of a artistic R&D. But I would say that this is kind of similar in a lot of ways to, for example, the early the early id software development, right? Like when they came out with Doom, like nobody had anything that could do that. Right? It was like a new tech development, and people had to go clone what they did. A lot of people couldn't. I think at least like maybe one person maybe did, but a lot of people just had to license it, right? Because just nobody had that. When they came out with Quake, nobody had that, and then that was mostly the end of it. They never really did anything after that was something pretty far beyond what people had, but that was 2 in a row. You might argue Wolfenstein was too, but that depends on how you do it. But definitely Doom and Quake, it was just plain new technology that no one else had. And so we aim to do that, basically. And so we're trying to do that to a certain extent. And when we ship a game, we try to have an argument for why there's something new in it that's, an actual technological achievement that you can't just clone. And so I'll just close on last one regarding story engines. What sort of advancements are in yours, if you can mention anything? What does it achieve? Yeah, we won't really ever be talking about it, probably. You'll see the game when it comes out, or rather, you'll probably see it earlier than that, right? You'll see some, demo footage and stuff like this. And it should be pretty obvious, at least in terms of what the quality bar is and also the level of interactivity, which should both be dramatically higher than what you've seen before, but it's not going to be something that's ever going to be talked about. It's private tech, and will remain so, if that makes sense. All right, I'm going to close it down. All right, thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. It comes with a source code so you can experiment with it. Maybe you would like to go into the code and think about like a good exercise to do now that we've got the sound going is we may want to put in protection or have a theory about how we would prevent sound skipping in the case where we can't hit our frame rate. Now, I don't really ever want to be in a situation where we're not hitting our frame rate, so I'm not sure how much I really want to do that. But it sometimes helps to just have a way to do that just in case. So that's something to think about, and you could play around with that and think about how we might accomplish that. I'll be back tomorrow for some more look at probably the audio stuff. We probably want to go through and clean some stuff up. Maybe look at... I felt like there was some clicking in there. We want to try and simplify the mixer a little bit. So I think we should just maybe do a little bit of audio cleanup now that we've got it working. I think that would be a good thing for us to try. That's about it. I'll be back here tomorrow, same time, same place. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.